Good morning, ChemCom students. Happy Friday. This is Mr. Dawkin. We're going to go ahead and continue our notes on density here. We're going to cover density, and then we're also going to do a little bit of graphing skills. Okay, so we're going to take notes over these. Again, if you need to print your notes, go ahead and print those out on your own, or take notes by hand on a piece of paper. Either one will work just fine. Okay, so we're here with density. Yesterday we finished here talking about the density of water, which was 1 gram per milliliter. And anything with the density less than 1 is going to float. Okay, anything with the density less than 1 is going to float. Anything with density more than 1 is going to sink. So the Coke and the Diet Coke in the demo video that you watched, the Coke, the regular Coke, sank because it had a density greater than 1. The Diet Coke had a density less than 1, so it floated. Okay, so we're going to move on. The formula for density is mass over volume. Okay. M is for mass, V is for volume, and we have 3 variables here, mass, volume, and we have density. Each of these things has units attached to it. Mass is in grams, volume is in milliliters, and density would be a mixture of the two, grams and milliliters. We can rewrite this formula to solve for mass and volume. So I think, okay, sorry, I had to figure my marker out there. So if we want to rewrite this formula to solve for mass and volume, I can use this triangle here. For instance, if I want to solve for mass, I would cover it up. And what's left on bottom is density times volume. So if I'm solving for mass, that's going to be density times the volume. Okay, I want you to write that down in your notes if you would. Pause if you need to. Now, if I need to solve for volume, down here, I'm going to cross it out, and what do I have left? Volume is going to equal mass divided by density. Okay, so that's a way that we can rearrange the equation. So if you'd like to go ahead and jot that triangle down, that would also be good. Pause if you need to. So what is the unit for density? Well, if the units for mass is grams, and the unit for volume is milliliters, when we divide the two, the unit for density is going to be grams divided by milliliters. So the units for density are grams divided by milliliters. Remember, a material has the same density no matter how big or how small it is. So my College Station mug, no matter if this was the size of a coffee mug or if it was the size of the school, the density of this would be the same. If you have a cup of water versus a swimming pool of water, the density of the water itself is the same. Alright, so here's an example that we may see. A piece of metal has a volume of 4.7 milliliters and a mass of 53.7 grams. What is the density? Well, they gave you milliliters, that's a volume, and mass of 57.3, it says mass there. So what is the density? So the mass is 57.3, volume 4.70. Here's the equation for density, mass over volume. So we're going to divide mass divided by volume. And here's the answer we get. And what we're going to learn how to do eventually is round this correctly. So this is our correct answer, 12.2 grams per milliliter. So I'm going to start asking you questions. Would it float or would it sink? And the answer here is it would sink because the density is greater than 1, the density of water. Pause if you need to finish writing that in. We're going to graph a little bit in this class, not too much, but we need to know the basics of graphing. A graph of density and volume can be used to find the density of a substance. The slope of that line formed when mass and volume are plotted is the density, and we're going to use rise over run because that's the slope of the line. So on the y-axis we have volume, on the x-axis we have mass. Okay. So what you need to know is that when we have a slope with the variables of density, we can find the density from the slope. When graphing something, remember dry mix. You may have learned this in junior high. Dry is the dependent variable, is going to be on the range, which is the y-axis. So that's up and down, dependent. Mix, the manipulated variable, the m, is on the independent variable side, which is the x-axis over here. Two types of variables that we can have. We have independent and dependent. Independent variable is what you change in the experiment. The dependent variable depends on the independent variable. Okay, so the independent is what you change in lab, and the dependent is what changes because of what you changed. So in density, the dependent variable would be volume. Volume is going to depend on how much mass you have. If you have more mass, the volume is going to get bigger. The independent variable is mass. Again, if you change the amount of mass you have, the volume is going to change with it. Remember, a good experiment only has one variable that changes, the independent variable. You only want to change one variable in an experiment. The dependent variable changes in response. It depends on what you change. All the rest of the variables, this is important, are the same. Those are called control variables. We control them because we keep them the same. And we're going to finish here on notes. Another example, an oil tanker has a leak and spills 20,560 milliliters of crude oil into the Gulf of Mexico. This same oil has a mass of 17,900 grams. What is the density? Well, once again, we have a volume and a mass. So we just need to divide the two. 17,900 grams divided by 20,560 milliliters. Here's our final answer, 0.87 grams per milliliter. Oil floats on water. So does it make sense that the density is less than 1? Yeah, density less than 1, it's going to float, just like the Diet Coke. So how do you think this affects the cleanup process? What if oil sank to the bottom? It would probably be really hard to clean up. We can't really just go to the bottom of the ocean every time we want to clean up something. So because oil floats, it's actually a good quality, so we can clean it up better.